next topic we are having, that is angular torque. Okay, so angular torque, so what does it mean? It means that the circulation of a body, that is called the angular torque after acting upon a force. So as you guys all know, we are having a formula of the torque. In the previous video we have discussed about the torque, so we have derived the formula. So we were having the formula that was position vector into the force is equal to the sine theta. Was the formula of torque. So we are having that if sine theta, we are having the 1 degree, so we are calling as a 1. Okay, so we can write here that torque is equal to rf only. Okay, so as you all know that f is equal to force is equal to ma, so we can write here as the force like ma. Okay, after that we are, as you guys all know, the formula of the acceleration we were having, that was the radius into the angular radius into the angular acceleration. Okay, so we were having this one formula. After that, angular acceleration. So as you all know that we are having the angular acceleration, so we can write here that torque is equal to the r m, and acceleration is equal to the radius into angular acceleration. So we can write here that radius into the angular acceleration. Okay, so here you can see that radius into radius is equal to the, this is the mass, and this is the radius into radius, and radius square, and dot alpha. Okay, so this is another formula of the torque. So here you can see that if we talk about the torque angle, so that is always in the 90 degree. For example, I am having this one. So here this is the radius, and this is the mass that is acting. So if this is rotating, so the direction of the force will be upward. Okay, and here the degree is the 90, so the torque is always in the 90 degree. And if we talk about the half, so that is in the 30 degree. So if we talk about this mr square, what is mr square? Mr square is basically is equal to the moment of inertia, that is called moment of inertia. So the moment of inertia is also called the rotational inertia, angular mass. Okay, so what is the moment of inertia? What does it mean? It means that the moment of inertia is basically the body moving in a circular motion. Okay, like this, a body is having the radius as well as the mass is acting, so this is in the circular, the body moving in the circular motion, that is called the moment of inertia. Okay, so if we talk about this one like this, so this is basically what, so we are like we are having the formula that is angular mass, or you can say that the moment of inertia is equal to the mr square. Okay, so we are having this one formula of the moment of inertia. So as you guys all know that we are having linear motion. We are denoting as m, simple m. If we are having the, you can say that the circular motion, so we are denoting as the I, which is, this is linear motion, and this is circular motion, the angular motion or circular motion, so we are calling that as the moment of inertia. Okay, from the second law we have got that if f is equal to ma. Okay, but in the linear motion, if we are having that like the, you can say that this torque is applied on a circular motion, this was under linear motion, so we can write here that torque is equal to the, this one, moment of inertia dot alpha. Like we were having a formula equal to r into the f. Okay, so we are also having the torque one formula, that is moment of inertia into the, you can say that, alpha. Okay, so this was about the torque, angular torque. Okay, so if we talk about that the SI unit of this one, or not this one, this one, yes, if we talk about the SI unit, so as you guys we are having the mass SI unit, that is kg, and radius we are having square, so we can write in the meter square. Okay, so the SI unit is the kg into the meter square. If we talk about the dimensions, as you guys all know, the dimension of this one, kg is denoted by, this is the formula of what, mass, so we can write it mass, and this is the meter square, which is the length. Okay, so length is in the square, so we can write here this is the dimension of the moment of inertia. Okay, so this was about the angular torque. In the next video we will discuss about the angular momentum. So we will derive the formula angular momentum by the this one formula. Okay, so that will be more easy to understand. So the next topic we are having, that is angular momentum.